So in the next part of the algebra review, what we're going to look at is some different things involving factoring. So one of the more important skills that you need to have as you move into pre-calculus is the ability to factor. So we're going to start off with some basic, pretty easy basic kind of factoring problems and kind of move into some that are a little more difficult. So remember, when you're factoring, and there's a couple different ways of factoring, but the most common way to factor is you're basically taking a problem and you're trying to basically do FOIL in reverse. So remember that if we're going to try to, for instance, with part A here, we're going to factor x squared plus 9x plus 20. Remember, you're looking at the first term here of the trinomial, and you're basically asking yourself, what times what is x squared? And that's what's going to go in the front of the parentheses. Well, when you go to do this, x times x is x squared, and that's what goes in the front there. Then what I want to do is I want to take the 20, and I'm going to kind of just over here list some of the different possibilities of numbers that I can multiply that equal 20. So for instance, I have here 1 times 20, right? There's, let me try that again, 1 times 20. I got 4 times 5. I got 2 times 10. And what I want to what I want to try to do first here is, if I don't know what the numbers are that go in the back of the parentheses just from looking at the problem, what you always want to do is first try numbers that are closest together first. So for instance, with this, because this is a positive 20, what that tells me is that the signs in the parentheses have to be the same, because the only way I could multiply two numbers together and have it equal positive is to do either a positive times a positive or a negative times a negative. So those are my two choices as far as the types of numbers that go in the back of the parentheses. Now, in terms of which of the type I'm going to choose, that's when I'm going to look at this middle term here, and since that middle term's positive, that tells me that these two are going to both be plus signs. And if I put a 4 and a 5 here, what you notice is if I do the outside-inside part of the FOIL, x times 5 is 5x, 4 times x is 4x, and if you put those together, it equals 9x, which is the same as what's in the middle here. So that's how I know that I'm right. And that's the answer there for part A. For part B, I got the same thing here. I got the two empty parentheses. So since this is x squared, this is going to be x times x. And then I have here factors of 10 would be 1 times 10 and 2 times 5. And once again here, notice because it's a positive 10, that tells me that the signs in the parentheses are going to be the same. That means they're either both going to be pluses or both going to be minuses. So I look in the middle to know which of the two it's going to be. So since it's a minus in the middle, that tells me that these are both going to be minuses. And if I put a 2 and a 5 in at the back of the parentheses there, x times negative 5 is negative 5x. Negative 2 times x is negative 2x. And if you put those together, you get negative 7x. So that's the answer for part B. For part C, notice it's a minus at the end, which is going to make the signs in the parentheses a little bit different. So x squared is still going to be x times x. And then 15, the factors of 15 would be 1 times 15 and 3 times 5. So because it's a negative 15, what that tells me is that the signs in the parentheses have to be different. One has to be plus and one has to be minus. And that's because the only way you can multiply two numbers together and have it equal a negative is to do a positive times a negative. So with this here now, it matters where I put the 3 and the 5. So if you notice in the middle here, it's a positive 2x. So if I put the 5 here and the 3 here, now if I do the outside-inside part of the FOIL, x times negative 3 would be negative 3x, 5 times x would be positive 5x, and when you put that together, that equals positive 2x. So that shows me that part C is correct. For part D, I have, once again, a minus at the end, so this will be x times x, because the first part of this is x squared, and then the factors of 6 are 1 times 6 and 2 times 3. So once again, because it's a negative 6, that tells me that the signs in the parentheses are going to be different. And if you notice in the middle here, this is negative 1x. So if I were to put a 2 here and a 3 here, now if I do the outside-inside part of the FOIL, x times negative 3 is negative 3x, 2 times x is 2x, and when you put those together, that ends up being negative x. So that's the answer for part D. So those are just some different factoring problems where the coefficient in front of the first term, the coefficient in front of x squared, is 1. But as you've probably seen in a lot of different factoring problems, not all problems are like that. So here's the other type of problem that we're going to look at in terms of just some basic factoring problems. In this part A here, this is what's called a difference of two squares. So if you notice with this is x squared minus 25. If you notice with this, the middle term is missing. So what this really means, x squared minus 25, really means x squared plus 0x minus 25. So just notice that with 0x, we don't write that because 0x would be 0, but I'm going to leave that there because when I go to factor this, now I got x squared here, so this is going to be x times x. And if you notice with this, since it's a negative 25, because it's negative, that tells me the signs are different. And then the factors of 25 would be 1 times 25, and then 5 times 5. And what I'm looking for here is numbers that I can put in the back of the parentheses that when I do the outside-inside part of the FOIL equals 0. Well, that in this case would be 5 and 5. Because if I did x times negative 5, that would be negative 5x. And if I did positive 5 times x, that would be positive 5x. And if you put those together, that ends up being 0. So that's the answer there for part A. For part B, I have here m squared minus 22m plus 121. So I'm going to do the same thing here. I'm going to put m's in the front of the parentheses. And since that's a positive at the end, that tells me the signs are the same. The minus in the middle tells me they're both minuses. So 121, I have here 1 times 121, and I have 11 times 11. So you can see here, if I put 11 and 11 in, now if I go to check this, this would be m times negative 11 would be negative 11m. Negative 11 times m would also be negative 11m. So this would be the answer for that. So since both parentheses are exactly the same, another way to write the answer to this would be just to say m minus 11 squared. So sometimes you might see it written like that as well. And that's just some different things involving factoring with what are called some special patterns. Some other factoring problems are involved with things like this, and that is when you have a coefficient in front of x squared that is not 1. So as far as how we're going to factor these, we're not going to do this any different than what we just did. The only difference with this is that we're going to have, instead of x squared, it's 2x squared. So when I go to do this, I'm going to have, instead of just saying x times x, this is going to be 2x times x. So now when I go to figure out the numbers that go at the end here, so notice this is plus 7, so that tells me that the signs are the same, and then this tells me that they're both going to be pluses. So now what I have to figure out, the factors of 7 are simply just 1 times 7. I have to figure out where will the 1 go and where will the 7 go so that when I do the outside-inside part of the FOIL, it will equal 9x. So if I were to put a 7 here and a 1 here, and I go to do the outside-inside part of the FOIL, 2x times 1 would be 2x, 7 times x would be 7x, and when you put that together, that equals 9x. So that's the answer for part A. For part B, notice with this one I have 5x squared instead of just x squared. So I'm going to do this here. I'm going to have 5x times x. And once again, since the value at the end is positive, that tells me the signs are the same. This tells me they're both negatives. So I got that there. So now the factors of 6 would be 1 times 6 and 2 times 3. So once again, I have a couple different possibilities for numbers that I can put in the back here. So I'm going to start with, since I'm not exactly sure which pair is supposed to work, I'm going to start with the numbers that are closest together. So I'm going to try 2 and 3 first and see if that works. So I'm going to put a 2 here, I'm going to put a 3 here, and I'm just kind of guessing at this point to see if in fact that would work. So to check it, I have to do, once again, the outside-inside part of the FOIL. So I'm going to do 5x times negative 3, that's negative 15x. And then I have negative 2 times x would be negative 2x, and that is going to work because if you put those together, negative 15 and negative 2, that comes out to be negative 17x. So that's the answer for part B. For part C, I have a 3 in front of the x squared. So I'm going to put this in here. So this will be 3x times x. and then the factors of 2 are just 1 times 2, and notice it's a negative 2 at the end, so that tells me that the signs are different. Now here's where you have to be careful about putting your signs in, because the terms that are in the parentheses right now are not the same. They're different. So where I put the plus and where I put the minus is of significance in this case. So at this point I really just have to kind of try something and see if I can get it to see if it works. So I'm going to put here, I'm going to put in a plus 2 and a minus 1, and I'm going to check that and see if it works. So I got here 3x times negative 1, that's negative 3x, and then I have positive 2 times x, that's positive 2x, and if you put those together that equals negative 1x, so that one is going to work. So the answer to this would be 3x plus 2 times x minus 1. And then for part D, I have a 7 in front of the x squared, so this would be 7x times x. And once again, notice it's a negative at the end, so that tells me that the signs are going to be different. So I run into the same problem with part D that I ran into with C, in that I'm not exactly sure where the plus goes and where the minus goes. However, I do know the factors of 3 are 1 times 3. So I know that those are the numbers that I use that are going to go in the back of the parentheses. So once again, I have to try something just to see if it works. So I'm going to try here like a plus 1 and a minus 3. And I'm going to see if that gets me somewhere. So when I go to do this, 7x times negative 3 would be negative 21x. 1 times x would be positive 1x. And when you put those together, that would equal negative 20x. So that's the answer for part D. For part E, now notice with the parts A through D, the numbers in front of x squared, 2, 5, 3, and 7. If you notice, all of those numbers were prime numbers, meaning that the only numbers that those values are divisible by are 1 in themselves. And that's significant because with part A, what we had in the beginning of the parentheses was just 2x and x. For part B, it was 5x and x. For part C, it was 3x and x. For part D, it was 7x and x. Well, now for part E, it's a little bit different because the number in front of x squared is no longer prime. It's a composite number. So 4 has a couple different possibilities. There is 1 times 4, but there's also 2 times 2. So in terms of what I would want to try in the parentheses first, it's the same rules that I showed you, or that I talked about with you, that applies to the numbers in the back of the parentheses. If you're not sure what to do, always try numbers that are closest together first. So I'm going to do 2x and 2x here first. Notice here it's a positive at the end, so that tells me the signs are the same, and then this tells me that they're both pluses, so I'm going to have that there. And then the factors of 5 are simply just 1 times 5. So I'm going to put a 1 in, I'm going to put a 5 in, and it doesn't matter where the 1 and the 5 go because both of these are the same. Now I'm going to do the outside-inside part of the FOIL to check and see if it's right. So I got 2x times 5, that's 10x, and then I have 1 times 2x, which would be 2x, and if you put those together, that equals 12x. So that is in fact correct. So that's the answer for part E. For part F, once again, notice the number in front of x squared is a composite number. So for 20, I got a couple different possibilities. I got 1 times 20, I got 2 times 10, I got 4 times 5. So once again, because I don't know which pair of numbers is the one that's going to work, I'm going to first just try 4x and 5x. I'm going to try that first and see if that gets me anywhere. And then for 6, notice it's a negative 6. So that tells me the signs are going to be different. So for this, I got 1 times 6 and 2 times 3. And I'm not sure where the plus and the minus go. I'm not even sure. I'm going to try 2 and 3 first, and I'm not sure where the 2 and the 3 go with this. So with this one here, what I'm going to try maybe here is I'm going to try like a minus 3 and a plus 2. See if that gets me somewhere. So one of the things to keep in mind when you're talking about plugging numbers in the back of the parentheses, okay, and this is sort of just a general rule of thumb for factoring, you don't ever want to put a number in the back of the parentheses, and maybe I should back up here for a minute. You don't ever want to put a number in the back of the parentheses that has a factor that's the same as a number that's in the front of the parentheses. So if I have 2 and 3 here, what I don't want to do is I don't want to put a 2 here, because 2 and 4 have factors that are in common. They both are divisible by 2. That never works when you're factoring. So what that tells me with this is if I'm going to try 2 and 3, I want to put the 2 over here and the 3 here. So now when I go to put my signs in, I'll put a minus here and a plus here. I'll see if that maybe will work. So when I do 4x times 2, this will be 8x. And when I do negative 3 times 5x, that's negative 15x. And when I put that together, that would be negative 7x. So that in fact does work. So that's the answer for part F. So as we move on to some other things involving some different things that are similar to example 2 with special patterns, notice with part A here I have a difference of two squares again. So this would be 16x squared. Once again, the middle's missing, so it's really plus 0x minus 49. So one of the things to keep in mind with this is that anytime you see a factoring problem where the number in the beginning and the number at the end are both perfect squares, chances are what you're going to have here is a difference of two squares, where I'm going to have here 4x and 4x, because that's the square root of 16. The square root of 49 is 7. So I have that there, and since it's a negative 49, that tells me the signs are different. So if I do the outside-inside part of the FOIL, 4x times negative 7 is negative 28x. Positive 7 times 4 is positive 28x. And if you put those together, that equals 0. So if you ever see a difference of two squares where the middle is missing and the numbers at the beginning and at the end are both perfect squares, chances are what's going to go in the parentheses is simply just the square root of what those numbers are. For part B, same thing here. Notice that the term in the beginning and at the end are perfect squares. So 9y squared, I'm going to break this up to be 3y and 3y. 49, I'm going to break this up to be 7 and 7. And if you notice it's a positive 49, that tells me the signs are the same. And since it's a plus in the middle, it tells me those are both going to be pluses. So if I check this to see if it works, 3y times 7 is 21y. 7 times 3y is 21y. And when you put those together, that equals 42y. So that shows me right there that those are that works. And then for part C, same thing. Square root of 25 is 5. Square root of 121 is 11. So I have here 25z squared. I'm going to call this 5z times 5z. And then 121, square root of 121 is 11. And once again, it's a positive 121, so that tells me the signs are the same. This tells me they're both minuses. So when I go to check this, 5z times negative 11 would be negative 55z. Negative 11 times 5z would be negative 55z. Put those together, you would get negative 110. So that's how I know that that works right there. So that's some different things, once again, kind of relating to what we did in the second example with this, or the third example. So some other things that are involved with factoring, and it has to do with some different things involving GCFs, otherwise known as greatest common factors. So whenever you're factoring and the terms of what you're factoring have factors in common, what you want to always try to do is always factor out what you can that they have in common. So for instance, for part A here, I have negative 3y squared and negative 18y. So if you notice with this, with negative 3 and negative 18, I know that negative 3 can go into both of those. And I also notice that they both have y's in common. So what I want to do is I'm going to factor out a negative 3y. So to figure out what goes in the parentheses, what you do is you take what's factored out and you divide that into the two terms. So negative 3y divided by, or negative 3y squared divided by 3y. The negative 3's cancel. Y squared over y is just y. And then negative 18 divided by negative 3 is positive 6. And then these y's would also cancel. So one of the things that you check to see if you're right here is you just take what you factored and you distribute it and make sure it equals the original. Negative 3y times y is negative 3y squared, and negative 3y times 6 is negative 18y. So that's how you know what you did was correct. So if you take a look at part B here, notice that 5 can go into each one of those parts. So when I go to factor out the 5, everything here gets divided by 5. So 5 divided by 5, that cancels, so I got z squared. 25 divided by 5 is 5, so this would be plus 5z. And then I have 40 divided by 5 would be 8, so this would be positive 8 there. And if this could be factored, I would want to look to factor that, but if you look at this here, you can see that this is a trinomial that can't be factored. So that's just going to stay z squared plus 5z plus 8. For part C, notice with this I have a negative in front of the square terms. I want to factor that out. And then notice that 2 can go into each one of these terms, 4, 10, and 24. So I'm going to factor out a negative 2 here. And when I do that, everything gets divided by negative 2. So here, negative 4 divided by negative 2 is positive 2. Negative 10 divided by negative 2 is positive 5. And then 24 divided by negative 2, so that should be an m there. This would be negative 12. So now what I want to do, and this is squared. So now what I want to look to do is I want to look to try to factor this. So one of the things to keep in mind whenever you're looking at a trinomial and you're trying to figure out if it can be factored or not, if you recall from some different things that you may have done with the quadratic formula, there's the part that's underneath the square root of the quadratic formula, which is known as the discriminant. And the discriminant is b squared minus 4ac. So what we know is true about the discriminant is this. If you take a trinomial that you're trying to factor, and if you do the discriminant or the value of the discriminant for that trinomial, and if you notice that when you do that, the value that you get is a perfect square, meaning you can take the square root of that number evenly, what that tells you is that trinomial can be factored. So what I'm going to do here is I'm going to take, for this one here, I have a equals 2, b equals 5, and c equals negative 12. And I'm going to do the discriminant for this, and I'm going to see if I get a perfect square when I do that to see if it can be factored. So when I go to do this, I'm going to pull up my calculator here. So I'm going to do here, let me clear this out. So I'm going to do 5 squared minus 4 times a, which in this case a was 2, times 12. And the value that I get when I do this is negative. So what that tells me when I go, or is that negative 12? That's a negative 12. So let me pull this back up again. So this would be a negative 12. And when I go to do this, I get a value of 121. So 121 is a perfect square, because if I take the square root of 121, that equals 11. So since the discriminant, or the value of the discriminant, is a perfect square, what that tells me is that this trinomial here can be factored. So what I'm going to do here is I'm going to just sort of erase this over here. And that's good to do, is because now I know if as I proceed forward, I know that I'm working with something that can be factored. So I have this negative 2, so I'm going to open up my two parentheses. 2m squared would be 2m times m. Negative 12, so that tells me that the signs are different. So 12 could be 1 times 12, it could be 2 times 6, it could be 3 times 4. So once again, since I'm not sure which pair of numbers is going to work, I'm going to try the pair that's closest together first. But with this, keep in mind, if I'm going to try 3 and 4 first, what I don't want to do is I don't want to put the 4 here, because that is going to have factors that are the same as this, and we know that that never works. So if I'm going to try 3 and 4, I'm going to try this first. So now I know the signs are different, so maybe I'll try maybe a plus here and a minus here, see if I can get that to work. So when I do 2m times positive 4, I'm going to put this up here, that's going to be 8m, and then I have negative 3 times m would be negative 3m, and if I put those together, that ends up being positive 5m. So I know that that works, so that's in fact what that's going to be there. So that's just some different things, a lot of really good things there involved with Part C, with greatest common factors, as well as some different things with factoring, the result that you get once you factor out the greatest common factor. For Part D, notice the two terms here are both divisible by 4. So I'm going to do this, and I'm going to divide both of these by 4. 4x squared over 4 would just be x squared, and then negative 4 divided by 4 would be negative 1. And then notice with this here, I have a difference of two squares. So I'm going to open up two parentheses here. X squared would be x times x. Negative 1 would be plus 1 and minus 1. Right? So if I put those together, that's where the 0x comes from in the middle there. So that's just some different things there with Part D. So that's some different things with factoring. And like I said, if there's one skill that is of the utmost importance when we're talking about some different things that come up in pre-calculus, it definitely has to do with factoring. One of the last algebra reviews that we're going to look at has to do with some different things involving inequalities. In particular, how to solve both a absolute value inequality as well as a quadratic inequality.